Hey, welcome back to AI Tech Hub. I'm Techie. So today we're answering a pretty massive question in the world of modern data architecture. What actually is Apache Kafka? You've probably heard the name thrown around in tech circles, maybe seen it pop up in job descriptions, but in this explainer, we're going to break down exactly what it is, how it works, and why it's basically become the absolute backbone of the data-driven systems we use every single day. Because, well, here's the fundamental problem, right? For decades, we relied on traditional databases that just store data at rest. You query it when you need an answer. But today, applications don't just need data sitting in a vault. They absolutely require data in motion. We need systems that react instantly to a continuously changing reality, and that massive shift toward event-driven architecture, that's exactly what Kafka was built to conquer.
Okay, let's dive into this. To really understand the sheer scale of what we're talking about here, just consider the mind-boggling number of operations happening behind the scenes. Trillions. Literally trillions. When you look at tech giants like Netflix and Uber, they aren't just handling a few notifications here and there. No, they rely on Kafka to handle trillions of messages every single day. To put that into perspective, think about a ride-hailing app during peak rush hour. In just 1 second, that system might generate millions of distinct events. I'm talking rapid-fire GPS pings tracking a driver's exact location, surge pricing calculations, complex matching algorithms trying to pair you with the car, all happening instantly. If a system like Kafka went down for just 60 seconds, the financial loss and operational chaos would be catastrophic. We're talking about critical data points moving seamlessly across the globe. But how do you even begin to manage that level of relentless data traffic without your entire infrastructure just completely crashing?
Well, that brings us to part one, the digital post office, and how we manage all this data chaos.
To understand how Kafka handles that chaos, I want you to picture something. Imagine a massive, bustling post office right in the middle of the busiest, most chaotic holiday shopping season you can possibly fathom. You've got millions of packages flooding in from everywhere, all at the exact same time. The logistics are a total nightmare, right? But somehow every single one of those packages needs to go to the correct destination in the exact correct order with absolutely zero lost mail. Well, that flawlessly run post office, that's exactly what Kafka is, but for data. It acts as the ultimate logistics manager for your architecture. Let's map this back to the actual tech. In our digital post office, the systems dropping off the packages are what we call producers. The downstream systems waiting eagerly for their data, those are the consumers. And the massive sorting facilities making sure everything goes to the right place, we call those the brokers. Kafka is basically a highly robust cluster of these brokers designed to take in absolute chaos from your producers and instantly turn it into perfect, reliable order for your consumers.
Now, you might be wondering, what actually are these data packages we keep talking about? How does this translate to real-world business impact? In the digital world, these packages are constant, vital events being sent from a huge variety of different systems. A package could be a tiny event stating that a user clicked a button, an order was just placed, or a payment successfully went through. But it's not just a simple digital receipt. Think about the cascading value of that one single event. When a payment goes through, that one package needs to instantly trigger fraud detection algorithms, update global inventory databases, notify shipping and logistics, and send an email confirmation to the user, all simultaneously. Literally, every single digital interaction generates a critical business event, and it needs to be routed perfectly to multiple downstream systems so the business can react in real time.
So, how does this actually build into a workflow? The magic formula essentially boils down to three core actions: collect, organize, and deliver. First, Kafka reliably collects all those fragmented messages from the producers. But the absolutely crucial part is how it organizes them. Instead of just dumping everything into one massive pile, Kafka organizes messages into specific categorized channels called topics. You can think of topics almost like highly specific mail chutes. You might have a topic just for payments and a completely separate topic just for new user signups. This means that when it's time for the third step, deliver, a consumer system only pulls the specific data it actually needs from the relevant topic. It doesn't have to sift through a mountain of irrelevant information. Kafka keeps perfect order without dropping a single piece of data, seamlessly connecting the systems generating the data with the ones that desperately need it.
And this brilliantly illustrates part two, real-time data streams and understanding the continuous flow. So, the crucial takeaway here is understanding the massive paradigm shift in how we handle information today. This is exactly why Kafka's architecture is so incredibly powerful in the modern tech landscape. You see, traditional data systems were often built around batch processing. It was essentially like waiting for a massive truck to fill up with data over several hours or even overnight before finally making a single delivery. They handled one-time deliveries, single, isolated actions that happened once and were done. But Kafka completely flips that model on its head. It is fundamentally built for continuous streams of real-time data. It treats data not as a stagnant pool, but as a constant, flowing river that literally never stops. It isn't just about moving a single box from point A to point B anymore. It's about perfectly managing a never-ending, high-speed conveyor belt of critical information, allowing companies to react to events the very millisecond they occur.
Which brings us to a really fascinating question to leave you with today. If there is a constant, unending stream of trillions of messages, how does the actual message ordering work? Like, how does Kafka use underlying mechanisms like partitions and numerical offsets to absolutely guarantee that a payment confirmation message always arrives after the order placement message and never before it, especially when millions of things are happening simultaneously across a massive distributed network? It's a brilliant, highly complex puzzle, for sure. And if you want to see exactly how that flawless ordering system works under the hood, I want you to comment the word stream right now. Seriously, I read all of them. If you found this explainer helpful for understanding the big picture of Kafka and event-driven architecture, make sure you hit that follow and subscribe button. We break down a brand new, highly complex concept every single time to make learning efficient and engaging for you. Thanks so much for joining me on AI Tech Hub, and I'll see you in the next explainer.